welcome to Steam Culture. We're wrapping up our series on steamships by doing our final view of the Titanic. And before I get into it, I want to say thanks to all the historians and writers and researchers and graphic artists and designers that have put together all this great content that I've been researching for our Titanic series. I'm going to put some links in our description. I want you guys to go have a look and you won't be disappointed. There's so much detail on the Titanic that I want you to go look at. You're going to find it interesting. But let's get into it, okay? So last week we talked about the boilers. We've made steam. So here's the general view of how the propulsion system worked in the Titanic. So steam leaves the boilers. It travels in these long steam lines that travel above the bulkheads, heading towards the rear or the aft of the ship. Now, they're introduced into two reciprocating steam engines, triple-expansion, four-cylinder reciprocating steam engines that generate 15,000 horsepower apiece. Those two outside engines turn the outside propellers. When the steam work is done in those engines, it heads to a manifold, then goes to a single turbine, which turns the middle propeller. When all the steam is used in that middle propeller turbine, it then goes to a condenser, where it's condensed back into water and taken back to the boilers for feed water. They didn't waste any of the steam. All right, so here's a little information on each one of those steps. So on these triple expansion four-cylinder steam engines, the steam was introduced into the first cylinder, which is the high pressure cylinder. Now the steam acted on both sides of the piston, pushed it down and pushed it up. The steam came into the high pressure cylinder at 215 pounds. After it had done its work and given up a little steam pressure, it was sent to the intermediate cylinder at 78 pounds, where same process happened. It moved the piston up and down. When it left the intermediate pressure cylinder, it went to two low pressure cylinders at 24 pounds. Now, why would it have to go to two low pressure cylinders? Well, remember, at higher pressure, you don't need as much steam volume. The energy is in there. As the pressure decreases the volume of the steam, you need more room. So each individual cylinder, high pressure, intermediate pressure, and low pressure, got progressively bigger. When they got to low pressure, they actually needed two cylinders to do the work, so that's why. So back to the low pressure cylinders. We're now at 24 pounds. The steam does its work on the pistons. It leaves the low pressure cylinders at 9 pounds. So we've gone to 215 down to 9 pounds. It hits a manifold and heads to the steam turbine, which again is turning that middle propeller. It does its work at just 9 pounds and turns this massive 12-foot diameter turbine that turns that single propeller. After it done its work on the turbine rotors, it exits the turbine and goes to a condenser at just 1 pound. So in the condenser, they bring in cold seawater to cool down the steam, take it from its gaseous state back into a liquid state, and send it back to the boilers to be used as feed water. They didn't waste any of the steam that they created, and they really couldn't because they needed all that power. But it's a great setup. It's really interesting to see how the technology worked and how efficient they were with the use of their steam. So again, I'm going to encourage you to go out and look at all these links because there's so much information that I think it's really interesting and I think you'd really enjoy it. Well, thanks for joining us on this whole journey through steamships, finishing with the Titanic. Join us next Friday on Steam Culture. I'll have some more content for you. In the meantime, while you're waiting, go find us on social media because we're everywhere. We have content for you. I will see you next week.